In this case, we are going to be looking at the question that reads as follows. Let's just call this example number 4. 2 into root x plus 1, right, plus 1 is equal to 20 over 2 into root x plus 1. Okay, so when we look at this thing now, this defies a little bit of our algebraic, or rather the algebra that we're learning in this section in terms of the quadratic strategy, because one, we said we shouldn't be working with fractions, but two, we also said we shouldn't be working with roots, right? And so how do I isolate the root here when I have so many roots? And there's probably a way to do it. We're going to look at one of the easier ways, and that's when we see something that is common, right? So I've got that and I have that. And remember, when you see things in common that may look a little bit complicated, we can use something called substitution, or we can use the K method. Okay. Right. So from previous sections, you should have seen how we can look at the K method. So in this case, we're going to say, okay, let K equal to the following: 2 into root x plus 1. So wherever we see root x plus 1, we can simply change that into K, because that is K. So this is going to be K on that side, K plus 1, that's my K, right, and that's also K. So K plus 1, that whole thing was K, plus 1, is equal to 20 divided by K. Okay. No punny. Okay, so let's look at that. K plus 1 equals 20 over K. Let's look at this here. Yeah, sorry, so now we have fractions, and how we get rid of fractions is we need to apply something called the lowest common denominator. In this case, the lowest common denominator is K, and also a restriction with that is that K cannot equal to 0, right? Because then this whole thing becomes undefined. So when I multiply everything by K, I multiply that by K, I multiply that by K, and I multiply this by K. And because I've got an equation, I don't need to write this over the LCD. The LCD will automatically let things, the equation will allow the LCD to fall away here. So K times K gives me K squared. 1 times K is plus K, is equal to 20. Okay. Right, so what can we do now? Now we can simply say that that's going to be K squared plus K minus 20 is equal to 0. Factors of 20 is subtract to give you 1. I'm going to break that up into K and K. This gives me K. That's going to be 5 and 4, and that's going to be K as well. Right? That's going to be plus 5 and negative 4, and therefore K is equal to 4. K equals negative 5. Okay. Righto. Okay, but we're not done, because we've got K equals 5 and K equals K equals negative 5 and K equals 4. So I'm just going to back substitute that. I'm going to put it in over there, and I'm going to say, okay, I've got K is equal to 4, and we know K is actually equal, is this whole thing over here, 2 into root of x plus 1 is equal to 4. Okay, so what can I do here? I'm going to square both sides now, because the root is already on its own. And when I square this thing, I get 4 multiplied by x plus 1. I didn't write and show you the square there, because I take it that's something you know, is equal to 16. Okay, divide both sides by 16, I get x plus 1 is equal to 4, and therefore x is equal to 3. Okay. And then on the other side, I've got 2 into root x plus 1 is equal to negative 5. And this cannot be, because I've got a root. This thing is always positive. It's always greater than 0. And a positive multiplied by 2, which is a positive number, positive multiplied by a positive can never be negative. So this here is invalid. Okay, please just repeat that. If you don't get it, just rewind, because a square root is always defined as a positive thing. It's greater than 0, and 2 itself is a positive number, and positive multiplied by positive has to be positive, so this cannot be negative. The solution is not valid here. Okay. Righto. Okay. Right, let's just trick everything there. This was 2 into square both sides. I get 16. Square this, I got 4 into x plus 1. Divide that, I get 4x plus 1, x equals 3, right? You could have also said 4x plus 4, and then you would have been able to, let's just look at how else we could have done that. We could have said 4x plus 4 is equal to, yeah, it's equal to 16, and 16 and 4 cancel out, leaves me with 12, and then I've got 4x is equal to 12, and I divide both sides by 4. I would then end up with x is equal to 3. Okay, so that's another way that you could have continued with this thing over here. Okay, and that's example number 4.